Hello everyone and welcome to this Mobile World Live webinar. I'm Kavit Majithia, the Senior Editor of Mobile World Live, and I'm delighted to be your moderator for today's event. Over the next hour or so, we are going to be exploring the topic of LTE IoT devices and how to ensure maximum battery life, with a look at design choices and power-saving features. Before we start, we'd like to gauge an idea of how advanced our audience is in rolling out LPWA. So please take a second to fill out our poll question, which you will see on your screens now. Thanks. To explain this in greater detail, I'm delighted to be joined by our two speakers today. First off, we have Jitendra Vora. Jitendra is Director of Product Marketing and Carrier Relations for the North American market at Telit. Hi, Jitendra.
Hello.
And secondly, we have Anna Jukovic. Anna is the Product Manager at Telit, responsible for the LTE NB IoT product lines. Hi, Anna.
Hello, everybody.
Just before I hand over to Jitendra to start the presentation, a few words on Telit. Telit is a global leader in the Internet of Things enablement with an extensive portfolio of wireless connectivity modules, platforms, and services. Now, while Jitendra and Anna are presenting, I'd like to encourage our audience to interact by posting comments and questions. We will have time at the end of the presentation to address some of those questions. Simply submit a question in the box underneath the slides and we will try to answer it. And also, I'd like to draw the audience's attention to Telit's new white paper, Designing Cellular IoT Devices for Battery Life, which is available to download in the Resources tab on your screens. IoT is a very broad term, meaning its needs are very diverse, from high-speed use cases for applications such as video surveillance, to low speed for sensors, to low latency for voice communications, and large capacity for dense deployments. However, there is always one common requirement, and that is for all of these devices to have low power consumption and longer battery life. To lower power consumption, LTE technology can play a major role. This webinar will focus on the power-saving features supported in LTE IoT LPWA technology, as well as how to decide the best LTE technology for the target use case and how to optimally design and provision IoT devices to maximize their battery life. We will start with the steps it takes to design your LTE devices for maximum battery life, including needs, challenges, and options. And we will also cover the IoT evolution in detail. And with that, Jitendra, over to you.
Thanks very much, Kavit. Once again, I would like to thank you all for joining today's webinar. Anna and I are very excited to talk to you about designing your LTE IoT device for maximum battery life. I believe this topic is very interesting since the majority of us are holding one or even two LTE devices in our hands that are all battery powered. We plug our cell phones into the outlets to charge or even drop them on the wireless charger daily. I realize some of you may be wondering what we will talk about during this webinar, since LTE devices are already battery powered today. Well, the focus today will be on IoT LTE devices. These are different than cell phones. Charging your IoT device several times a week is not what people consider low-power battery-operated devices to be in the world of IoT. Before I move to the next slide and start my presentation, I want to be sure you are all clear on a couple of additional areas. First, I want everyone to be clear that LTE-M and narrowband IoT are fully 5G forward-compatible technologies. I also want you to be clear that the burden of power savings is on the designer. Low power is not out-of-the-box capable. It is not a silver bullet. You just don't get instant 10-year power savings after locking down a module on the design. There's more to it than just that. Achieving low power is on you as a designer. We want you to understand your choices. The application needs to be designed for power savings. The network needs to be supported. It is incumbent upon the IoT device OEMs and the system integrators to select the right module and within the module the right mix of features to optimize the performance of the device. In addition, you also need to carefully configure the features and the behavior of the module in the proper way to maximize battery life. This slide highlights the type of questions you need to ask and answer when you start a new IoT project and want to fully understand all the design choices in order to maximize battery life. It is important to fully understand the needs of the use case in terms of the 8 areas mentioned on this slide. I will not go into details on all 8 due to the time constraint and because Anna will also touch upon some of these later in the presentation. But let me start off talking about number 1 and number 2, considerations for battery life. This is always data speed and the amount of data traffic involved. The faster the speed and the more data you need to transmit and receive, the more power is consumed from the battery. Now let me jump to latency. This is important to understand any minimum latency requirements. Your outgoing data can get away without latency because you can establish the connection at any time, but it's really the incoming data latency requirements. If you can be more tolerant to latency, you can extend your battery life. Maybe during business hours, you support 2 or 3 minute latency, but during off hours, you're able to do more towards 30 minutes or possibly even an hour. By doing this, you greatly expand your battery life. Now I will jump to the ability to charge or replace the battery. Another big one for designing battery life is the cost and possibility of reaching the device for the purposes of replacing or recharging the battery. So how often do you do that? I know some utility meter companies, specifically water and gas meter companies, specifying meters to be touched or maintained. The batteries on these meters need to be replaced once every 10 years per the regulators at a minimum. Specifications like these are important to take into your calculations. Now I'll skip the last 2 bullets since Anna will touch upon a bit later when she covers some of the design and device related parts by talking about Release 13 and Release 14. So in the last slide, we looked at the different dimensions that need to be considered when doing the design. Well, this slide highlights where all the demands and constraints are coming from as we look across the wide spectrum of applications shown on the slide, such as mobiles, such as video security and wearables, just to name a few. Clearly, all of these areas are addressable by the diverse needs of IoT serviced by LTE. Now, with the aid of this slide, I wanted to talk about the entire ecosystem of IoT. Cellular IoT specifically addresses a wide range of applications and services, including the 9 shown in this slide. I wanted to quickly highlight the ones that rely heavily on low battery power and have significant cellular IoT traction out there today. So let me start off with smart cities. So within smart cities, I wanted to focus on smart parking. Most of the parking meters are not connected to power and have little solar power cells with tiny batteries. For the most part, they are relying on solar and local battery. On mobile health, a similar story with the wearable devices. Those devices monitor people's glucose for diabetes. Obviously, you don't want to require the user to either replace or recharge the batteries every few hours. Smart utilities. Anything that isn't on power, such as gas and water and steam, for example, you need to be able to use battery on anything like meters. So it's very critical here. Environmental monitoring. So for agriculture, you're measuring the soil's acidity, the soil's humidity, air contamination, air chemistry, and pollutants. You may do this outside of a setting where an electric grid exists, that you can plug your device into power. A lot of this is happening on battery-powered devices that are connected out there with cellular. Connected building. I'll skip this one because there's not a lot of applications that require battery power. Connected industrial, also not a lot of applications that require battery power, as there's usually power around them. Connected retail. In this area, there are lots of battery-powered point-of-sale card readers that don't plug into phones or tablets. So they need batteries that can last for long periods of time such as a week or even more before they need recharging. And of course, asset tracking. This is probably one of the most important spaces because you want assets like pets or kids or something important that is possibly being shipped from a farm to a consumer to be tracked through the whole supply chain journey. As you can see, these broad mix of applications have a diverse set of needs. Now, I wanted to talk a bit about LPWA, or Low Power Wide Area, which is a new category of technology that has been created to address a specific need. Low power because this is the power consumption of the IoT device. Wide area because this is about long-term communication. I will start to talk about LPWA from an unlicensed perspective first, followed by a licensed perspective after a few slides. So I realize some of you may be in a situation where you are trying to determine which of the two technologies that I'm showing here to select. This slide highlights 6 important dimensions that are highlighted in orange and compares them across 2 technologies. I'm hoping this will help you decide which path to take. First is unlicensed. There are a number of standards out there, but the most popular ones are Sigfox and LoRa. These would fall as part of the left column. Second is cellular, such as Cat-M, NB-IoT, that is shown on the right. The world of low power wide area started off with unlicensed standards and did quite well. Back then, cellular was not a good fit as it was not very battery friendly and did not satisfy power requirements. But now, with Release 13 and the launch of narrowband and LTE-M, cellular is a viable option. It will get even better as the standards evolve. Anna will explain in more detail shortly. In conclusion, on this slide, I wanted to reiterate that one technology is not necessarily better than the other. They're just different and should be chosen based upon your use case, based upon your application, and the impact on the battery, as we talked about. Now let's move on and touch upon low power wide area from a cellular perspective. This slide highlights the 3 major cellular standards that are straight across comparisons to some of the unlicensed standards, such as Cat1, NB1, NB2, and Cat-M1. For example, earlier in my presentation, I spoke about LoRa. We can find the corresponding type of functionality to LoRa in Cat1 and Cat-M1 depending on the application. Sigfox, for example, is usually between Cat-M1 and NB1. I also wanted to highlight with Cat1 you get global coverage. With Cat1 today, voice is supported, and it is possible to use Cat1 with either single or dual antenna. Cat-M1 and Narrowband 1 are still in the rollout phases. These networks are not fully deployed worldwide, and roaming is still limited in comparison to Cat1. Both M1 and NB1 are low power, low cost options with single antenna. They also offer extended coverage, and by that I mean in-building coverage. I wanted to wrap up my portion by highlighting advantages of cellular low power wide area. You get 3GPP, which is a global standard supported by hundreds of networks. Due to this, you are getting into a much bigger ecosystem. The beauty about 3GPP cellular standards is that they are being maintained and evolved for a long time span. There's no interference. With cellular LPWA, you get global availability. So if your device needs to go all around the world, coverage is needed in every country, in every corner of the country. This is possible. Cellular LPWA provides secure transmission by providing encryption. Mobile applications and mobility you get with cellular, but not with LoRa and Sigfox. As I mentioned before, LTE-M and NB-IoT are future-proof, and that's what 5G future-proof says. So you may be wondering in more detail what this means. What I mean by that is 3GPP has decided to evolve both of these technologies into the upcoming releases of the standard to be compatible with 5G new radio network. This practically means that in order to have LTE-M and narrowband IoT fully integrated into a 5G network, you will require a software update of the module and of the application. The 3GPP cellular standards offer different flavor of the technology to satisfy a variety of use cases with different requirements, such as mobility and quality of service and real-time applications. So this concludes my portion of the presentation. I wanted to thank you all for this opportunity. Now, as I would like to introduce my colleague Anna, she will cover main features for LTE-M and narrowband IoT for optimizing power consumption a bit more technically. Over to you, Anna.
Thank you, Jitender. Good morning again, everybody. My name is Anna Ukovic. I'm product manager at Cellular, responsible for the LTE-M and urban IoT product lines. During my part of the presentation today, we will take a look more in details about the cellular LPWA technologies and what are especially the features that will help in saving power for battery-based applications. So, first of all, let's have a look to the differences between LTE-M and urban IoT. So the first difference is in the data speed and, of course, consequently, the latency that you can get with those technology. So when talking about LTE-M, so Cat-M1, and we're talking about 3GPP release 13 devices, the data speed is up to 375 kilobit per second, while in the case of narrowband IoT, so release 13 MB1, for example, we are talking about tenths of kilobit per second. So this is one thing that has to be taken into account in the design, depending on the use case that you are going to address. Another difference in LTE-M is that LTE-M does support full mobility. So, for example, use cases such as transportation can be served using LTE-M, and LTE-M does support voice. So, voice over LTE is available for LTE-M, and this is useful in use cases such as security for alarm panels, but can be useful too in use cases such as wearables for personal emergency systems. So, these are some of the examples. In the case of narrowband IoT, narrowband IoT is best suited for stationary application. Here you can see some examples, some of them already mentioned also in the Jitender presentation. So an example of use cases is metering, for example, is smart city or smart agriculture. Let's go more in detail about the features that are available for LTE-M and urban IoT devices that can help in increasing the battery life. So first feature defined for those devices is power saving mode. Power saving mode is very useful in case of application requiring mobile originated communication mainly or scheduled transmissions. Okay, in this case, you can benefit of this feature which is available for LTE-M and urban IoT devices. Let's see an example. An example can be a water meter that needs to transmit data just once a day, and for the rest of the time can go to sleep and be unreachable at the end. Or in case of some alarm, for example, abnormal water consumption, it will need to send some messages to the server. Okay, this is one example. How PSM works. So basically, if you take a look at the picture here in this slide, the device transmits the data, then listen to the paging to see if there are incoming messages for him, and then goes back to sleep. Okay, once he wakes up again to the new transmission, then it does not need to register to the network again, and this is the advantage of using PSM. We have to say and be careful that PSM and also EDRX that we will see in next slide is a negotiation between the device and the network. So basically the device asks to use PSM with some timer, and by the way, the timer in which the device lives can be as long as several days. Okay, then the network has to accept the timer requested or to assign some other timer that are defined in this network. So it's a negotiation every time between the device and the network. To give you an idea of the current consumption that we can reach in this state, so when talking about standby or idle mode for the devices, for the modules, we can have like 8 or 10 milliamp current consumption. When talking about PSM state, we can reach down to few microamps. So you can see how much is the advantage. Another very important feature which is available for LTM and narrowband IoT devices, which help in saving power, is the extended DRX. Basically, this feature addresses application in which you need to reach the device and you have mobile terminated communication. An example. So an example can be use cases of object tracking. So you need to reach the device to check about his position, but still you can accept some delay in getting the answer. So you can accept some latency. That can be, for example, 5 minutes. Okay. In this case, EDRX feature, which is available for LTM and narrowband IoT devices, can be very useful. If you take a look to the picture in this slide, so basically the interval between paging occasion for standard LTE devices is usually a few seconds. With extended DRX feature, this is extended up to more than 40 minutes in the case of LTM and about 3 hours maximum in the case of narrowband IoT. So basically, the power consumption that you can get using this feature can go to below 1 milliamp current consumption and also down to a few tenths of microamp to give you the idea of which is the advantage in this case with this feature. So in this slide, I'm going to present another important feature which is available for LTM and narrowband IoT devices, which is the extended coverage or enhanced coverage feature. Basically, this is an increase in the RF link budget with respect to standard LTE devices. This increase in the case of Cat1 is up to 15 dB. In the case of narrowband IoT is even higher. We are talking about 20 dB increase in the coverage. Okay. So also this is something that you have to consider in the design. So if you think that the devices in your application are going to be installed underground scenario or in building scenario with back coverage, probably narrowband IoT is a good choice because of this feature up to 20 dB, better than standard LTE. Why this is important also for the topic today, so about power consumption and battery power application. Because on the one hand, you have the advantage of having better coverage, okay, of the device. But on the other hand, we have to say that this is achieved during retransmission and repetition of the signal. So at the end, this will introduce some latency in the communication and in general will consume more power in your device. So this is also something to be taken into account in the design. So basically, the advantage that you get using Power Class 5 is that you can have devices and modules with a simplified and highly integrated design. This means lower cost and size. The power consumption will be also reduced when in transmission using 20 dBm output power, and this is true in good coverage condition. In the case the device is in bad coverage condition, we have to consider in the design the device supporting 20 dBm can enter in coverage enhancement mode sooner than devices supporting 23 dBm. So we have to consider also this because, as explained in the previous slide, with coverage enhancement we introduce retransmission and repetition that at the end will make the device consume more power. So the features that we have seen so far basically are defined in 3GPP release 13. Okay, 3GPP release 14 and 15 specifications are already available from the standard. Regarding release 14, we have seen last year the first commercial deployment, but in terms of network, deploying release 14 features and devices, so module, for example, Intellit portfolio supporting release 14. Okay, basically there is an evolution of the standard in 3GPP. Now, currently, work in progress is on release 16 that is expected to be released this year. The message here is that all the enhancements that are introduced in every 3GPP release are aimed to go to the 5G deployment. In the case of cellular LPWA, 5G means massive IoT deployment. So every time a new release is out, there are new features also for cellular LPWA, so LTE and urban IoT devices. And here you can see some of the examples that are enhancing all this technology, and especially when talking about power consumption. So in the next slide, we will take a look to some new feature from release 14 and 15, just to give an overview. So one very important feature in release 14 is the higher data rate. In the case of Cat-M1, release 14 devices are able to support up to 588 kilobit per second in downlink and 1 megabit per second in uplink, while in the case of release 13 for Cat-M1, we were talking about 300 in the range of 300 kilobit per second. In the case of narrowband IoT, release 14 has introduced MB2. MB2 does support data rate of hundreds of kilobits per second, while MB1 only maintains tens of kilobits per second. Why this is important and relevant also in terms of power consumption? Because this higher data rate can be very useful in addressing some use cases. And an example is when the device needs to perform the FOTA. FOTA means firmware upgrade over the air. So basically, the size of the file that the device has to download to upgrade the firmware can vary from few kilobytes to 1 megabyte or more. So if higher data speed are available, this means you can download the file sooner, okay, and this will save power in your application. Here in this slide, there are some examples of some new feature introduced in release 14 and 15 that help in reducing the power consumption and decreasing the latency. So those are very important in the case of battery power application. First example is the release assistance indicator. This for narrowband IoT has been defined already in release 13. and is already supported by some of the network and is already supported, for example, in Telit modules. Okay, how does it work? So basically, the device with this feature can indicate to the network that it doesn't expect further data, so the connection can be released earlier. So this is one example. Another example, defining release 14 and then better defining release 15, is the relaxed monitoring for cellular selection. So basically, with this feature, the device can monitor the neighboring cell just as seldom as every 24 hours. And this is very useful in the case of stationary devices, maybe in challenging coverage conditions, okay, also to save power. The third example is wake-up signal. This has been introduced in release 15. This is useful when the device is in DRX or eDRX. So with this feature, the device does not need to monitor all the time and decode the page signal, but in case there are incoming messages for him, the network sends a wake-up signal to the device in order to make it available to decode all the paging signal. So also this is an advantage in the case of battery power application. What is important regarding all those features is that basically the current release 14 modules and chipset are expected to be upgradable with the new feature introduced both in release 14 and release 15. So the path continues towards the 5G. So as already highlighted by Jitender, LTM and Narrowband IoT are 5G ready technologies. With this, I conclude my presentation. Thank you, everybody.
Thank you, Anna. So yeah, we've still got time for some questions, and we've had some in. So Anna, if we stay with you, what are the advantages or trade-offs between using power saving versus turning off the modem?
So basically, in the case of using power saving mode, when the device wakes up to transmit the data, it does not need to register to the network again. So this is an advantage also in terms of power consumption. There are cases in which you have to consider the trade-off between switching off completely the module instead of going power saving mode. This depends. In the case of switching off the module, what can be done is just to disconnect also from the power supply in order to save also the microamp that it will consume in power saving mode. So this is also an option, but has to be considered depending on the design and probably on the frequency of the transmission needed by the application. Because as I said, you have to consider that when you wake up, you need to re-register to the network that you don't need in the case of power saving mode, which is a negotiation between the network and the device.
Right. And Jitender, if we go back to you, does IoT always need a SIM card to connect to a network? How do you optimize battery life when dealing with GNSS GPS location?
Okay, I'll take that one. So yeah, thanks for asking that question. Let me address the first one first regarding the SIM card. So 3GPP technology requires SIM card, but the industry is moving towards software SIM. So and then Telit, we also are offering this with our SIM-wise solution, which is more of a software SIM. So that's one thing that we can definitely, if there's interest out there, we can help out with. And the second question, in terms of GNSS GPS in general location, Telit offers a variety of location services. So we offer everything from like GPS and assisted GPS to cell ID. So depending on your specific needs and your use cases, we can help determine the best way to kind of move forward. So I welcome having any discussions with anyone on that topic.
Right. And Anna, we've had a comment for you. There are quite a lot of features in the toolbox for power saving for NB-IoT from FreeGPP spec point of view, PSM and eDRX release 13, Fast RRC release 13, RAI, CQI report, RA power ramping, etc. But in practice, not all of these toolboxes are supported either in the network side or the UE side. And the application layer usually is not the best way to fully utilize these features. How do you make sure the whole chain aligns to the same view from the application server to RAN, to the user experience, and the application on the UE side?
So basically, it is true that some of the features that are available in the standard, and we have seen some of them, are not all yet deployed. For example, the release 14 and 15 feature I presented in my last slide. So how we can know about this? So basically, as module vendor, Telit can help you in understanding which features are currently available in the module, so in the modem side, and which feature are in roadmap for the same modem. And so with this information, it's good that you can target the design to support current feature, but also upcoming feature if those are useful for your application. Okay. On the network side, of course, this is something that has to be checked for each network operator. We can mention that as Telit, we have regular meeting with the main MNOs worldwide, and most of our products are certified by the MNOs, and so we also can give and help in understanding which feature is available on this carrier or on the other carrier. We also perform a lot of field testing for this.
Right. And Jitendra, I was wondering if you could respond to a comment we've had. I agree that the global ubiquity of LTE M and NB are not there yet. North America is covered extremely well with both technologies. This person is from AT&T and said that he knows that its LTE M has matured well with millions of subs and nationwide coverage. Their NB is fully deployed but not yet utilized as LTE-M. They tend to compete on use cases right now. What's your response to that?
Yeah. I think it's a great observation, and basically I'm in agreement. And from a global perspective, MNOs globally are rushing to universalize the coverage of these two, low power standards, Cat-M and NB IoT. So so I'm in agreement with that comment also.
Great. And another question we've got, are there better solutions to get location information from devices?
Yeah. So basically, it is possible to get, I think I touched on it before, so we have a variety of location services we offer, from GPS, assistant GPS to cell ID. So that is something that we can help with.
Great. And this is for iReview. How can I monitor the actual power consumption and battery life when my device is deployed in the field versus expected calculations?
Yeah. So this one, Telit's our device management solution can help fulfill this need. By providing this capability, to kind of monitor and control the device behavior, including battery usage, remotely from a centralized dashboard. You're able to kind of monitor the battery level and then kind of report it to the control center, via the cloud when it crosses a threshold by reporting an alarm. So if you desire, you can also kind of trigger with this alarm a different configuration and behavior of the device in the field in a way that it goes into power savings mode. That goes into like a power saving mode, so it's less power hungry. So this is another area that we have a device management solution that we can definitely have further discussions on.
Right, Anna, we've got one for you. Can I use Release 14 compliant modules with a Release 13 network?
Sure. Yes, the answer is yes. So basically, if the module does support release 14 features, it does not mean that it doesn't support release 13. So basically, all the modules release 14 that support both release 13 features and release 14. In the case the network it connects to does not support release 14, it will just act as a release 13 device.
Right. And how do you select a best fit microcontroller unit for eMTC NB-IoT applications?
I can take that one. Yeah, so Telit supports AppZone, which is running like application firmware on the module processor to kind of eliminate the need for an additional processor. So that's kind of what we offer to resolve that.
Great. And another question we've got, what is the difference between higher CAT designs versus LPWA designs in terms of complexity, costs, and battery life?
That's a great question. Pretend you have a scale, and on the left end is 5G with the multi-gigabit speeds, and on the right side of the scale you have technologies such as Cat M1 with hundreds of kilobits of speed, and then all the way extreme right you have Cat NB1 with tens of kilobits of speed. So basically, the higher you go on the scale towards 5G, more towards the left, the higher the complexity and the higher the cost. The lower you go on the scale towards the right, Cat 1, Cat M1 towards NB-IoT, the complexity and the cost go down. The battery life is longer and the coverage is more expansive. So great question. So
excellent. And another question we've got: why is cellular or licensed LPWA so much smaller in terms of footprint adoption, in terms of nodes, than unlicensed?
Yes, thank you, Kavit. This is because unlicensed technologies such as LoRa and Sigfox, they've been around. They got like a 5-year head start compared to head start than LPWA with release 13. So 2G has not been battery friendly or even a low power solution. 2G is an always on connection and has no mechanism to be put in sleep. So cellular is not expected to take the lead, at least for several more years, because of the head start unlicensed technologies has had. So I think that's really the answer. But I just wanted to add, I've been kind of scrolling through some of the questions, and we're getting many questions regarding LPWA unlicensed technologies, different than LoRa and Sigfox. So we don't have the time to kind of go through each one of those unlicensed technologies, but I just wanted to say in general, I think the important takeaway when deciding between licensed and unlicensed is that with licensed, you are relying on a standard that will be maintained and evolved by a wide industry community over the years. Right? You also rely on a dedicated spectrum, so you can get a certain quality of service and reliability when communicating over licensed standards. So when you're thinking about unlicensed, regardless of technology, that's really the takeaway.
Definitely. And moving on from that, what main factors does maximizing battery life rely on?
Well, first of all, I just want to say today is my lucky day with questions, so thank you. The main factor, the first is the selection of the LTE technology, as we kind of talked about, for the use case to provide like device, optimum performance. The second is the specification of the device parameters. Typically, things that are associated with, local power consumption, including the peak speeds, the frequency of communication needed, like the sleep cycles, for example, and the type and size of the battery pack that the device can accommodate.
Right. I just want to take an opportunity now to tell the audience there is still time to ask questions. Just use the box underneath that slide presentation and we will do our best to cover it. Another one for you, Jitender, you're very popular. Do you get instant power savings for a specific amount of years by picking the right module?
Yeah, that's a good question too. So unfortunately, there's, like I mentioned before, there's like no silver bullet, right? So you don't It's more to it than just kind of that. The network needs to be supported. The application needs to be designed for power savings. I think I kind of touched upon this, but it's incumbent, upon the IoT device, the system integrators and the OEMs to select the module, and within the module, the right mix of features to optimize the performance of the device. So, you need to carefully configure the features and the behavior of the module in the proper way to kind of maximize the battery life.
Certainly. Great, and I think we've got time for one final question. How do we know the module is Power Class 5 versus the previous LTE Power Class?
So basically, this is in the specification of the product, and as Telit, we can help in choosing the right module according to your use cases. And we both have Power Class 3 modules for LTM and Urban IoT, and also Power Class 5.
Excellent. Well, that seems like a good place to wrap up. Thank you very much for taking part in today's webinar. A replay will be available shortly, so if you missed any of the content, you'll be able to catch up. I'd also like to remind the audience again to download Telit's white paper, Designing Cellular IoT Devices for Battery Life, which you can access in the Resources tab and on their website in the Resources section. Thanks again to Jitender, Anna, and thanks to our audience for taking part. We will see you again very soon. Goodbye.